Hey people, Pranksterman here. This video is going to be about piston and piston rod modification. There's a couple simple things you can do. It'll only take sandpaper and a little bit of know what you're doing so you don't screw up the parts. Show you the parts. For the piston, if you look at the surface, the head of the piston, the top part, this is the dish. If you run your finger across it, you'll feel the machine lines. See the machine lines in the shadows? It's basically taking 300 grit sandpaper, a little bit of oil, sand this down smooth. That'll get rid of any kind of hot spots. For the edges, round them off. This piston is already done. It was made that way, evidently. The Briggs & Stratton did it in their factory, I guess. All the edges are smooth. The only rough spot on the piston is the dish part. I'm going to take care of that. For the piston rod, I already did one side. If you look at the beam, you notice there's a casting line right down the middle of it. What you want to do is you want to smoothen this line down to a point where you can polish it, blend it in. That gets rid of any kind of stress risers. It'll prevent cracks at high RPM. Go all the way around. I've done this side. You can hardly tell that casting line is there. Flip it over, you can see it. It's a definite line. Just take sandpaper, 300 grit with a little bit of oil, smooth it down. You don't want to get too drastic. You're taking off metal. This part has to stay as thick as possible. You're just wanting to smooth this line here. You don't want to sand anywhere else. So I pretty much, how I did the one side was I rolled the sandpaper up on a piece of conduit and just went at it using the edges. Kind of hard to do with the camera. I'll show you a picture of it when I get done, when I get it all the way done. Till then. Okay, I'm back. I'm done working on the piston and the rod. I'll show you what I did. I actually did a couple other things too that I didn't mention in the first part. Let me show you the piston first. I shined up the dish part. If you look real close in the shadows and the light, you can see that it's smooth. You can still see the lines if you look at it, but it's smooth. Run your finger across it, you could tell. As I said before, you want to take down the edges along the rings, and then the edge here on this piston, it's rounded. It's rounded at the bottom, no sharp edges. If you were to do that, you would use sandpaper, add a little oil, get in there and sand it smooth. Or you could use a fine tooth file. That usually does the trick. For the piston rod, so for the piston rod, I've polished the beam all the way around. Got the top all the way over to the other side. If you look in the light in the shadows, you can see how smooth it is. I didn't take any metal off that I didn't need to. It still has its shape of a beam. The head of the beam's polished too, hand polish. When you take the sandpaper and you add oil and rub it on there, you're hand polishing it. While you're doing that, the oil breaks down the sandpaper and you make a finer grit, which is how it polishes it. Okay, the other modification that I made was the oil hole. It was originally just a drilled hole. I made the slot bigger. I don't know if you can see it. It's called a lead-in hole. Gives the oil more of a chance to lubricate the bearing when it goes through. There, that's a good shot. And what I use to grind that little slot is a little stone on the tip of my die grinder. I have an electric die grinder. Only took a couple minutes. Okay, and the other thing not mentioned in the first part is the piston rings. Set the camera down and I'll show you what I did with those. Piston rings have sharp edges. Take your fine-tooth file and you rub along the edges. These are the edges you want to work. You want them to where they're not sharp. The rings are sliding up and down the cylinder. There's a chance they could be digging in, so you take the file, you round them off, just like that, and then you take the file and you scrape the top to make sure they're flat when they're going up and down in the cylinder. They're going up and down inside the piston too. You want to make sure they hit the piston top and bottom flat, so you take the file and you slide it across. You'll see the scrape marks, you'll know it's flat. Any high spots will be shiny. Get rid of all high spots. Do both sides. Same thing. This is called tampering the piston ring. Go all the way around. You do that with all of them. There's no sharp edges. You could run your finger and you could feel the little round edge on them. And then you take the file, you round this off a little bit too. Nothing too drastic. You leave the inside alone. Same thing here. You scrape the top and you scrape the bottom to make sure they're flat. And I'll give you a demonstration on polishing the beam on the piston rod. What it actually does at high RPM. Stress fractures form. They form because when the piston comes up, you're actually coming to a dead stop, and when that happens, this piston rod is wanting to stretch. It being aluminum, when it stretches, it has a hard time of the grains stretching back. Aluminum has that problem. Cast iron and steel does it. Cast iron and steel, when they stretch, it'll go back, and there's really no harm done. Now, aluminum rods have a time limit that when they stretch, they have a hard time coming back, which creates stress fractures. That's how you blow the piston rod on aluminum rod engines. That's why you polish the beam. When you polish the beam, I'll give you an example what actually happens. Take a piece of paper for the example. I tore it so you have the jagged edge. You have thin spots, you have thick spots. It's not straight, which would be the example of the rod before I polished it. Basically, when you pull it, which is what happens with the piston rod, it's going to have a stress fracture somewhere in the middle, which it means it's going to tear. When I pull on a piece of paper, it's going to tear somewhere in the middle, and I'm only pulling on the top of the paper. so when I pull it, it's going to tear. Wasn't supposed to do that. Okay, let's try this part. Oh, see how strong that is? See how strong? You can't tear it. Actually made it stronger. I thought it was going to tear, but the ends broke. So let's try that again. That's how it was explained to me in school. They didn't exactly say where it was going to break, but I just assumed it would have been in the middle. Oh, there we go. It tore in the middle. So the piece of paper, this would simulate it being a polished rod. Wow, you see how strong it took just to break it? You could actually see the crease in the video. That's way stronger. Okay. That's why you would polish the beam on the piston rod. Wow, I learned something too. So, that's the end of this video on piston and piston rod modification. Rate the video, like it, hate it, subscribe if you like what you see. Prankster Man, bye.